Hello students, welcome back to MathFace Java programming tutorials. In this video, I'll discuss some programs based on square matrix. Let's see the contents. Introduction, main diagonal elements program, secondary diagonal elements program, and practice exercise. Let's start. A matrix with equal number of rows and columns, that is rows are n by n, is known as a square matrix of order n. For example, 3 rows, 3 columns. So square matrix of order 3. Now main diagonal elements. The diagonal from the top left corner to the bottom right corner of a square matrix is called main diagonal or the principal diagonal, and main diagonal represents the elements 0, 0, 1, 1, 2, 2, indices of a square matrix of order 3. So the elements at 0, 0, 1, 1, 2, 2 are 1, 5, 9. And how do we get this? We need some kind of formula. If you see, row index and column index are same, then only it is main diagonal. So the main diagonal elements can be displayed with the simple condition where row index equivalent to column index. This is true with any order of square matrix. In 4 by 4 array, 0, 0, 1, 1, 2, 2, 3, 3. So row equivalent to column. Row index is equivalent to column index. Let's see the program to display main diagonal elements. We've initialized an array 1, 2, 3, 4, 5, 6, 7, 8, 9 in ARR. Then an array is declared and initialized 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you see the row and column index j, k are the variables in the nested loop, j is 0, j less than r, rows and columns same. So we are taking j less than r, k less than r in the nested loop. When j is 0, k works 3 times. So 0, 0, 0, 1, 0, 2. When j is 1, 1, 0, 1, 1, 1, 2. When j is 2, 2, 0, 2, 1, 2, 2. But we are interested in where j is equal to k. So inside the loop we write, if j is equal to k, that is possible where 0, 0, 1, 1, 2, 2, only those areas. Print ARR of jk, that means the element. We are checking the index, both indices we are comparing and printing the element. If j is equal to k. Otherwise, we are trying to print only space. So, in place of 2, 3, 4, 6, 7, and 8, spaces would be printed and the output would be 1, 5, 9 in the diagonal way. Let's see the same program in the Java environment. Main diagonal, very simple program. We have initialized the ARR array and R row and R column is ARR dot length, that is 3. Jth loop works 3 times. Each jth iteration, kth loop works 3 times. 0, 2, 2. And if at all j is equal to j, if at all j is equal to k, print ARR of jk. Otherwise, print space. Let's execute and see the program. The output would be 1, 5, and 9. This is main diagonal elements. Now, secondary diagonal elements, what are they? The diagonal from the bottom left to the top right corner is called anti-diagonal or secondary diagonal. Secondary diagonal represents the elements in 0 to 1, 1, 2, 0 indices of a square matrix of order 3 here in the example. 0 to 1, 1, 2, 0 elements. What are they? 3, 5, 7. So how do we get this? If you see 0, 2, add 0 plus 2 is 2. In terms of indices only, we are trying to get the secondary diagonal. 1 plus 1 is 2. 2 plus 0 is 2. So in the secondary diagonal, if you add row index and column index, it is becoming 2 in a 3 by 3 matrix. So we need to use the formula where we are getting 2, but here 0, 0, 0, 1, when we add, they are not equivalent to 2. So the formula we can use is row index plus column index, that is 2 in a 3 by 3 array. So row index plus column index is equal to length of the array minus 1. If the length of the array, this is 3. 3 minus 1 is 2, and row index plus column index is 2 again. This is true with any order of square matrix. For example, 4 by 4 matrix. If you see the secondary diagonal indices, 0 plus 3 is 3, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 0 is 3. And the length of the array is 4. 4 minus 1 is 3. So row index plus column index is equal to length of the array minus 1. Let's see the program. We have initialized R is 3, taking a loop, and we are using the condition if j plus k double equals to R minus 1. R is 3, R minus 1 is 2. R minus 1 can be any order. If the length is 4, 4 minus 1 would be 3. If the length is 5, 5 minus 1 is 4. So this program works for any order of matrix. If j plus k double equals to R minus 1, then print ARR of jk. Then 3, 5, 7 are the elements which are matching the condition. Otherwise, print space. So the output would be 3, 5, 7. Let's see the same program in Java environment. Secondary diagonal program. We've initialized array R is equal to ARR.length, running a nested loop. If j plus k double equals to R minus 1, then print the element at ARR of jk, otherwise print space. Simple program. Let's execute and see the output. See 3, 5, 7. Now, how to access other elements in a square matrix? For example, lower triangle. In terms of j and k, j is the row subscript, k is the column subscript. If you see that red colored area, lower triangle including the main diagonal elements, 0, 0, j is 0, k is 0, j is 1, k is 0, j is 2, k is 0. In all these three cases, j is greater than or equivalent to k. Let's see 1, 1, 2, 1. 1, 1 is equivalent to 2, 1. J is greater than 1. Last 2, 2. J is equivalent to k. So we can find using j greater than equals to k. Then lower triangle with main diagonal elements can be printed. That is the condition. Let's see the next one. Upper triangle without main diagonal elements. If you see j is 0, k is 1, j 0, k 2, j 1, k 2. That means j less than k. In that case, we can access those three elements, j less than k, upper triangle without main diagonal elements. What if we want with main diagonal elements? Then j less than or equivalent to k, that is the condition. So the practice exercise is based on such kind of simple logical programs. Let's see the practice exercise now. So first one, upper triangular square matrix, where all the elements below the main diagonal are 0. For example, 1, 2, 3, 0, 4, 5, 0, 0, 6. Write a program to initialize the above array and print the elements of upper triangular matrix. Then second part, lower triangle square matrix. In this, all the elements above the main diagonal are 0. Example is 1, 0, 0, 2, 3, 0, 4, 5, 6. Now, write a program to initialize the above array and print the elements of lower triangular matrix. Third one, diagonal square matrix, where the entries outside the principal diagonal are all 0. For example, 1, 2, 6 is the main diagonal and rest of the elements are zeros. Now write a program to read a 3 by 3 square matrix and check whether it is a diagonal square matrix or not. Before saying yes, it is diagonal square matrix or no, please print the array, the matrix. Now fourth question is read a 4 by 4 square matrix and print sum of left diagonal elements, that is main diagonal elements, and sum of right diagonal elements, that is secondary diagonal elements, along with the matrix. This is your practice exercise. Refer chapter 7 of Essentials of Computer Applications for further understanding and practice exercises. The next video is about some programs on matrices only, programming logic on matrices. Thank you.